Okay, let's get started with this next session. So I'm Ash. I am on the analytics team at Planet, and today I'll be talking a little bit about how to begin packing your geospatial data science toolkit. And you might be coming to this talk from a variety of different perspectives. So my goal is to give you some high-level meta tools to help you find the right tools for you. There's unfortunately not a one-size-fits-all tutorial, and as we'll see, there is a wide ecosystem out there. And so my goal today is to start a conversation and to help you know some ways that I have found useful for exploring geospatial data, and to hopefully hear from you some of your favorite tools as well. So let's jump in. Spoiler alert, these two tools I find really useful no matter what I'm doing. So curiosity and perseverance go a long way in any data science project or in other projects as well. And it's true even if you're not going to Mars. So the first thing that I think is important when you're doing any data science project is to set out your vision. So what is it that you're trying to explore, or what questions are you trying to ask? So naming your journey is the first tool that I want to give you. Naming your journey can help you figure out what other tools you need. So for example, if you're going on an Arctic camping trip, you might not want the same things that you would need if you were going to stay at a summer cottage by the sea. So maybe you have a specific question. How many new homes were rebuilt in a specific town after a hurricane hit? Or maybe you have a more open-ended idea, like how can you explore the impacts of the pandemic in different parts of the world? So let's look at some examples of naming problems and goals so that we can think about how geospatial data might be able to help us with our problem solving. So in the span of months, COVID-19 has impacted our world, and public health really depends on spatial data for tracking outbreaks and monitoring the ongoing situation. So one question you might ask are, where are the case counts rising this week? Or how do the outbreak patterns correlate spatially with regional policy changes? Another kind of question you might ask is about something like deforestation. So over weeks or months or years, illegal logging roads can appear and trees can be lost. So what might we want to know about that? How much of the Amazon rainforest has disappeared in the past decade, for example, or in the past year? And which regions have the most illegal deforestation activities? Another really important use case is responding to disasters like floods. So if a community is impacted and the local government doesn't necessarily know how or where to deploy emergency responders, it can be a huge problem. So what might we want to ask in that scenario is, which roads are still accessible by ground vehicles today? How many people may need rescue and where might they be? Another really relevant topic is wildfires. So let's say we want to explore current fire containment efforts. Geospatial sensor data can help us with that. Which areas are at high risk for wildland fires in the next 5 years? They're modeling approaches that we could also take, and they're really relevant scenarios. There are a lot of aspects that we can look at. So naming your journey is part one. What are you looking for? That can help you know where to begin. Here are just a couple of other potential journeys. Of course, you probably have your own problem set or area or field of science that you might care about, but maybe you want to look at anomaly detection. Where did something new and unusual happen, and when did it happen? Or land classification, estimate which areas of the earth are covered by urban or forest or farmland. So after you've named your journey, you want to gather some data sources. So step one is to figure out where you can get relevant data. And it's important to be intentional and selective. This is the fuel for your project, so it will make a big difference. You don't want to end up packing a bunch of things that aren't really relevant for the problem at hand and forget something that will really be important to the problem you're trying to solve. So one starting point is to think about whether you can leverage or whether you need vector or raster data. So do you need kind of a summary of statistics in the form of points, or can you accept polygon boundaries that describe certain phenomena? Or maybe you're looking at sensor data and you want to analyze images from satellite, or maybe you want to look at data cubes that describe readings from some sensor. Another aspect to consider when you're assembling your data source is whether you want to work with a static and fixed data set that you can kind of take and then it won't really change because it's fixed, or maybe you need to think about how to analyze a dynamic data set that will have ongoing updates and change day over day. Do you need your structured data to have kind of queryable metadata? Do you need raster labels? It really depends on what problem you're looking at. So just to review, since this is an intro session, and I know people have different experiences with both data science and geospatial data, we often kind of straddle this world between vector and raster data, and these are just two formats in which to get those data. Of course, there are many others, but GeoJSON can help you share and look at vector data, and GeoTIFFs can let you share and look at raster data. So just to review GeoJSON, we can have points like this one that have coordinates. This is a point in San Francisco. We can have polygons like this one. This is a box, but they can be other shapes as well. And we can also have collections of many points or polygons. We can also have lines. So if you wanted to kind of have a specialized collection, you could represent some phenomena over time by putting special properties on each of these points. Maybe you could have different data sets that you import that already have this format. So Google Cloud has several public data sets available, and I'll walk through a little bit about what you might do with some of those. So here are some COVID data sets, for example. So in BigQuery within Google Cloud, you can query any of the existing public data sets in their query editor. So this kind of search bar lets you browse public data sets that are readily available for you to just query. You can then issue a query in this query editor if you know structured query language or SQL. And then you can see the results of your query below. So this query here was looking at some of the Johns Hopkins University confirmed cases for COVID in the past 2 days. And we can see region and case counts here by date. And there are other data sets, of course. This is a port data set. So the spatial data here in the COVID stats is represented actually as GeoJSON. So you can, if you're familiar with PostGIS, you can use similar functions directly in Google Cloud BigQuery. You can also have your data formatted in other ways. So this port data set has a port latitude and longitude, for example. So if you want to know where different ports around the world are, you can query this data set here. What's nice about this is that you can easily join these data sets together. So you could do a spatial join of one data set with another one, or you can join on metadata. And that really enables you to kind of flexibly query. You'll notice that this data is really vector oriented at the moment. So if you have a problem that can be formatted as looking at vector data, I really recommend checking out this tool and some of the free data sets that are out there. There are definitely other free data sets as well, and AWS hosts some. And then if you're looking at raster data, you might want to consider how can you find and discover raster data sets. So Stack will be a really great way for you to browse and search for relevant raster assets. So You might want to search catalogs and then filter for the assets that you need, read those assets in, and then analyze them. And Stack can be really helpful for helping you find the assets that you want. So here's an example of a planet disaster data set from Hurricane Harvey a couple of years ago. This lets us download or see which assets are available. We can preview them here in the Stack index, and we can download those rasters if we want, or we can just kind of read them dynamically if that's our preference. There's also Radiant Earth has a really great collection of machine learning data. So if you want to try to create models that automatically detect things like buildings or forests within raster satellite imagery, you can leverage these already labeled data sets that are indexed and searchable in the ML Hub from Radiant. So once you've kind of decided where you're going to get your data, you probably need to set up a workspace. So where are you going to be doing your analysis? Choosing your workspace is pretty personal and might have a lot of different constraints or influences. You might be working with a team. Maybe your team has preferences or already has an existing environment or ecosystem. Perhaps you have familiarity with a certain tool already and you want to see if you can use that tool you're familiar with. Or maybe the data set you're interested in is hosted somewhere and that hosted data set is readily available to use in a certain set of tools. So where are your data sets that you're interested in? That can really help you decide which workspace to use. And can you do your analysis with cloud tools and services in the same platform as where your data set is hosted? And maybe do you need to combine multiple data sets? That could influence what you end up needing to do. And then how big are your data sets? Do you need to ingest or register them into your preferred workspace in some way? So this can be done in multiple ways. Maybe you need to kind of have two parts where you ingest your data and format it and then analyze it, or maybe you can do your analysis in a streaming fashion where you don't have to ingest it and you dynamically read the data of interest and compute your results. There are also desktop or GIS environments that are specialized for certain kinds of layered geospatial applications. Some of these you won't necessarily need to be able to write Python code or a program to be able to use, which can be really great if you want to create a wider audience who can explore geospatial data. Google Earth Engine is another kind of really great hybrid tool. It allows you to both write code and do visualization in one kind of contained development environment where the data, the raster data is hosted on this platform, and you can run kind of large scale analysis of your raster data there. Of course, there are lots of other alternatives. You don't have to specifically use Earth Engine, but it's quite popular and has a lot of demos available. So if you want to explore what other people have done with geospatial raster data, you can check out Earth Engine. There are also Python notebook environments. So if you're just starting out on your data science adventure, or even if you've been around data science for a while, you'll know Python is quite well adopted in the data science community. It's also really popular among geospatial data analysts. So you'll see that there are different environments where you can run Python notebooks. So the Python notebooks are quite useful for being able to reproduce and share your analysis workflows so that someone else can either make sure they are working with different kinds of data or even with the same data set, and you can kind of alleviate people from having to reinvent things because you can fork or kind of remix pieces that are already in these notebooks. There are quite a lot of libraries out there that you might want to check out if you're doing a geospatial analysis in Python. These are just some of them. So the top row you might recognize if you've done sort of data science that's not strictly necessarily geospatial. This kind of middle section is geared toward specifically both vector and raster geospatial data. And then the bottom section is really more about doing machine learning on top of different structured or unstructured data sets. But how you combine these is really up to you, and whether you need them depends on the problem you have. You also, in addition to having an analysis toolkit like these libraries, you probably want somewhere to run your computations. So that could be a cloud compute environment. Some of these notebook environments like Colab or the Pangeo setup will let you kind of execute your notebook in an environment that's not necessarily your laptop. So you can be in a web browser and you can look at your notebook, and then you can have a cloud compute system somewhere else actually execute the analysis that's happening within your notebook. Although other strategies include setting up your own tools and services within one of these cloud platforms. You might also want to store your data in some form that if you reformat it or end up creating new assets, or if you want to register your data or index it in some way that it isn't already, you might put your data in one of these formats so that you can easily query and look for what you need during your analysis. Of course, once you've decided your workspace, you need to prep your data for analysis. So how can you access the relevant data from your workspace? Do you need to clean the data at all or validate it in some way? Maybe you need to actually merge multiple sources, so you might have to have some bridges or connectors that pull in data from many places and help you be able to merge it in some way. And then maybe your analysis can be done on the fly, or maybe you save an intermediate formatted data set. Here is one kind of ecosystem that might work for you. You could have an intake pandas X-array kind of workflow where you're dynamically reading rasters, computing some values from them and generating some reports. An alternative approach might look like this, where you have rasters stored in Google Cloud Storage and you can ingest them into Earth Engine. You can train some models with Google's AI platform, and then you can actually run machine learning models within Earth Engine now. So you could have trained a neural network to detect deforestation events, and then you can run that neural network within Earth Engine on new imagery. And then here are some examples from the Pangeo gallery. If you want to see notebook workflows, these are really great. You can launch Binder directly in your browser and go through these tutorials if you want to get a high-level overview of what's possible with this ecosystem. And then if you are totally new to Python and geospatial data, this is a hosted Colab notebook. If you go here, you can kind of get a walkthrough of how you would even start with doing something with pandas and geospatial data, and how do you even work in a Python notebook. It's really great that this Colab notebook will just run in your web browser. You don't need any special downloaded tools to use it. So another aspect of cleaning or validating or setting up your data set might be, if you want to train a machine learning model, you may need some labels. So there are tools like Groundwork that can let you generate new raster labels once you've decided maybe which raster images are relevant to you. Has someone else done the analysis you want to do before? So maybe someone's already trained a machine learning model like the one you want to make, and you've just added some new custom labels in a tool like Groundwork. So can you reuse someone else's notebooks or modify their setup or ingestion tools? It's ideal if you can borrow from other people so you don't have to reinvent these pieces. And just a note on data sets versus developing machine learning models. This is a quote or a tweet from Andrej Karpathy, who spent a lot of time thinking about modeling and algorithms during his PhD, but once entering Tesla, started thinking a lot more about data sets and cleaning and getting the data formatted and combined into a centralized or analyzable state. So that is kind of quite relevant in data science in general. Cleaning and validating your data are no small feat. So don't feel frustrated or let down if you find yourself spending quite a lot of time on step 4. It really is a key part of getting you to step 5, which is to be able to visualize and summarize the results that you are looking for. So I find this tool from Hoover, Kepler-GL, to be really useful for visualizations of vector data. There's also a number of ways you can visualize data from Google Earth Engine. So here's an example. We have both maps to show spatial trends, and we can plot line graphs as well. This is another oceanography example from the Pangeo gallery. So we can create visualizations like these directly in a Python notebook. And then BigQuery, as we saw earlier, has GeoJSON support. And on top of that, this tool, GeoViz, lets you take query results directly from BigQuery and plot them on a map. And then one last note, which is our team at Planet has thought a little bit about kind of bridging some of the tooling gaps between geospatial data and machine learning open source tooling. And the geospatial data kind of looks like this. Sometimes we have large geotiffs, they have many bands, they don't necessarily plug directly into machine learning model frameworks. So thinking about how we translate back and forth or bridge this gap can really help us leverage developments from outside of the geospatial world for solving geospatial problems. So the machine learning world, for example, has progressed quite rapidly in solving problems like semantic segmentation, so painting every pixel in an image based on the input data and determining which class each pixel in an image is, or object detection, like drawing bounding boxes around particular features in an image, or classification. And when you combine these, you can kind of leverage both aspects to create something like this, where we trained a machine learning model and then ran it over satellite imagery of the Earth to figure out where roads and buildings were. And then we zoomed out and made a sort of heat map of the current state of roads and buildings in the world. So you can't see what you can't fix, but you certainly have a lot of tools at your disposal for helping you see more about our ever-changing world. So a summary of what you might want in your toolkit is, first of all, having a vision. So name your journey and decide what it is you're looking for, and then pick some data sources. And indexes and catalogs of data sets can be really helpful in enabling you to get relevant data for solving your problem. And tools like Stack can really help make that data more discoverable so that you can spend more of your time focusing on the later parts instead of figuring out how to ingest or find your data. Then your workspace is really important. So making sure you have some kind of tool set that lets you do analysis of the kind that you need. And then you may need connectors, so software to either access or ingest or aggregate your data, and then report tools. So you want to be able to summarize and visualize your results so that you can share them with other people in a format that they can digest. So 2 more bonus tools for you are having a growth mindset will really help if you encounter challenges or hiccups or quirks or something doesn't exist or isn't compatible. So your failures can help you learn, and when things don't fit together, it's an opportunity for us to make new and better tools. And then community, so you're not alone. You can collaborate and explore with others, and I'm really glad that you're here today. And remember, there's no one-size-fits-all toolkit, so you'll need to pack your own, but you can always add more tools as you go. And I hope this talk, this intro to packing your data science toolkit will help you as you set off on your geodata journey. And I really can't wait to see what you find. So thanks again for joining today. I'm Ash, and I look forward to learning more from all of you. Happy to take any questions.
Awesome talk, Ash. I'm up next. Yeah, anybody in like 15 minutes, so we have lots of time for questions. Anybody have any? I have one for you, Ash. I'm curious what your personal daily toolkit looks like in your day-to-day job.
Sure. I think that it's a combination of what I'm working on and where I am. So at Planet, we have a lot of data in Google Cloud Platform already. So I'm leveraging a lot of the available Google Cloud tools for analysis and joining and querying and indexing. Kepler GL is my go-to for visualizing feature collections lately. It allows you to drop in a feature collection and it pops up on a beautiful filterable UI. And Jupyter notebooks, especially having tools like GeoPandas. Rasterio is my favorite for dealing with raster data, though I know people have other preferences depending on what they're working on. Yeah, those are a couple of my favorites.
Awesome. Does Kepler GL is there data sets that are too large for it? Like, do you find a limit of how much you can put in it?
I have hit a limit, but I'm not sure if that was a constraint of my browser or the tool itself.
Right. Yeah, I think it's a curiosity to me with just browser-based, because it's pretty pure browser-based, like sort of. So yeah, it kind of has to just deal with what the browser can.
Yeah, I'm really a fan of kind of quick to start tools. So not having to install something can really enable you to check it out without having to commit to it. Although there's definitely a time and place for having a kind of workflow that is running and hosted and downloading imagery if that's what you need to do. But I really like the accessibility of browser-based tools.
Yeah, that's cool. I should probably add those more to my toolkit. I think, like, yeah, should you know, could you build your toolkit early and then it's like, oh yeah, that's my toolkit. It's like sometimes you forget to like go out and explore the new ones and see if there's anything better to pack in your bag.
Yeah, and it's definitely great to learn from people who've worked in totally different ecosystems and to realize you have different paths for achieving similar things. And sometimes one way works better depending on where your data is or what problem you're looking at or what team you're collaborating with.
Totally. Does anybody else have questions? It's definitely super open forum. So anything you're curious about that you heard today or that Ash talked about, or a tool that you want to learn more about?
Yeah, I'll go ahead and ask one. Ash, in your view, what are some open opportunities for maybe new tools that might be needed in the community?
Yeah, that's a really great question. I think that there's a sort of set of fledgling tools that enable you to search and discover raster data. But the way that I think I showed this BigQuery example where you can kind of have this live ecosystem where you just query existing data sets and you can merge them together and you don't have to think about downloading or exporting or ingesting the data. I think having an environment like that one that that works for raster data would be really awesome. And I know people are working on several efforts that kind of feel like that, though I haven't seen a kind of holistic one that has lots of different data sets all in one without having to do some kind of ingestion. Earth Engine feels like that sometimes, but if I have another data set that's not in it, I have to do a lot of hoop jumping to get data into Earth Engine, or Pangeo has a lot of data sets, but not all of the ones that I might want. So there's usually some kind of having to put data from one place into another And it would be really great if there were analysis tools or kind of live query tools that enabled large scale analysis without data export. Maybe there are some that I don't know about though. So I don't know if you have thoughts.
I don't think there are, Ash. I think that's definitely, I think you have hit a key next one. And yeah, it was cool to see the BigQuery stuff and what that truly would mean for raster.
One area that really excites me is being able to represent raster data in alternate formats besides files so that we could query it. One approach to doing this is called semantic embeddings, or taking neural networks and kind of learning to represent the features of a raster image in a condensed format. And then you can run regression analyses on top of this embedded representation of an image. So imagine you have a big geotiff and you somehow learn or squash that geotiff into a 16-dimensional or 512-dimensional vector, and it's just an array of numbers that's much smaller and not, it's just 1D or squished in some way. Then you can kind of run analyses that are spatially indexed, but not necessarily doing pixel processing. I think there's a really big area for exploration in representing the raster data in some kind of database that it might be like BigQuery, or but having some kind of way that lets you do arbitrary exploration of information that's encoded in the image without having to look at the image yourself. Of course, some analyses need rigorous pixel analysis, but if you're looking for change detection or understanding patterns or trends over time, you might be able to work with formats that abstract away the pixels into another condensed format.
Yeah, that'd be super cool. Ash, do you see the question in chat? There's 2 questions in chat now.
Oh, great. Okay, first question. Is there a directory of tools for new people to learn the basics of geospatial data science? I don't know of a single directory. That's a really great question. I think the Pangeo Gallery has a lot of tutorials. I would recommend starting there. Does anyone else know of a sort of overview of the basics? I think I did post a link to one particular Colab notebook that you can just run in your browser that goes over several of those Python libraries that I mentioned. Oh, cool. Some people are sharing more lists in the chat. Thanks for that. And then another question from the chat was, what are some common GeoML models, and are they mostly deep learning? Also, could you point to some key programming tools for data exploration and munging? Regarding the models, a lot of modeling effort isn't deep learning. There are several kinds of modeling approaches. So one technique is called random forest, and you can actually train a random forest model directly in Google Earth Engine. You can create random forest models in a Python notebook as well with a tool like scikit-learn. As for deep learning, I think the use of deep learning models on geospatial data is a bit newer, still being kind of developed. The SpaceNet effort has been really great to see people collaborating, sharing training data in tools like Radiant's ML Hub is also really useful. So being able to have structured data indexed and labeled so that you can not have to assemble the data set, but can focus on the modeling lets you kind of separate those two concerns. Regarding exploration and data munging, yeah, I recommend having some kind of idea of what you're looking for, but like I said, visualizing your data can go a long way. So whether you're plotting it on a map or actually just inspecting your images with some kind of visualizer, that can help you understand what you're looking at. And yeah, Python notebooks or Python in general is really useful and has lots of libraries that might help you with your data exploration. So that slide full of libraries and several of these links are something I would recommend. Cool. And oh, I can share a link to that one collab notebook. Just a moment. I'm not sure if anyone from the Pangeo team is here. I'm actually not as familiar with that ecosystem besides doing a few pre-hosted tutorials. So I haven't set up the stack myself. Does anyone know how to answer this other question in chat? Is there an easier or recommended way to spin up a stack on AWS?
I don't. Yeah, I think Scott might be giving his session right now. Scott's with Pangeo, doing the intake stack. But I think that's the one that's happening right now. But yeah, Dave, we can definitely connect you to some Pangeo people. There's a few that have been crossing over the communities a bit. So I'm sure somebody that's not us will be able to get you connected.
Hello, Ash. I had a question.
Yep.
So in the talk, you mentioned how Planet was involved in kind of bridging data science and ML. Can you elaborate on that?
Yes, so actually a smallish team at Planet is exploring how we can take Planet's data set and apply machine learning models to extract interesting features in a lighter weight format. So Planet images the Earth every day and collects a lot of rasters, and we want to be able to let people know things of interest that have changed. So our primary analytic efforts at this point have been to detect roads, buildings, and objects like ships, airplanes, or well pads. And we can track those over time and notice if something has changed or create summary statistics reports about those features of the Earth. The summary statistics reports could be visualizations or CSVs. So that enables a wider audience to be able to consume Planet's data without having to download all of the rasters or without having to read all of the rasters. We also have visualization tools within our Web UI Explorer that let people see results of doing different analysis approaches. And we have a viewer for some of our analytics as well. It lets you see road and building layers on top of the satellite imagery. So you could consider ways of leveraging that to help you understand where you might want to actually download or look at pixels. So using the analytics layer as a sort of signal to help you decide which pixels you might actually want to be looking at could be one way of using or bridging that gap. Of course, there are lots of tooling choices buried within that connection. So what works for us may be different than what works for you, but we are happy to share ideas or thoughts if you have specific questions about, in particular, we prefer to use TensorFlow, and we've used scikit-learn on our team as well. So feel free to reach out.
Thank you.